Hey everyone, today we're jumping into a VS Code extension that's trying to do something really different. It's not about fixing your semicolons or your indentation. No, this is about the big picture. We're talking architecture, we're talking cost, and we're talking about the future readiness of your applications. Let's get into CodeMender AI.
All right, let's just kick things off with this quote from the developers themselves, because honestly, it says it all. This is the whole mindset shift right here. For so long, our tools have been obsessed with syntax, right? Well, this tool wants you to think bigger, a lot bigger.
And this slide just nails the core problem. Your linter? It's great. It'll spot a typo from a mile away, but it has absolutely no clue if that perfectly written function you just created is actually an architectural time bomb waiting to go off. CodeMender IA is playing a different game entirely. It's trying to predict why you'll fail at scale.
And I love the way they put this. What if you had a senior architect, that person with, decades of experience, sitting right over your shoulder, inside your editor, someone who could give you those deep insights on complexity, on cloud costs, and on whether your code is even ready for a microservices world? That's the promise.
Okay, so let's get official for a second. What is CodeMender IA? It's a DevOps intelligence engine. Now, there are two phrases there that are absolutely crucial. First, bring your own model. We're going to unpack that in just a bit. And second, its whole mission, finding logical fallacies, technical debt, and making sure your stuff can actually scale in the cloud.
And just to be super clear, this tool comes from the folks at SEOSiri. It's an important detail because they're not just building a one-off tool. They're positioning this as a key part of the modern DevOps toolkit, really focusing on that intelligence layer.
So let's dive into our first section here, the Universal Intelligence Engine. This is all about where CodeMender gets its brainpower, and more importantly, its flexibility.
This is that bring your own model idea, or BYOM, and it's a huge deal. Instead of being locked into one company's AI, it lets you plug in the one you actually want to use, or the one your company already pays for. It's all about giving you, the developer, freedom and control.
And here's the current roster. You can use Google's Gemini, which is great for quick checks, especially with its free tier. If you need some serious firepower for complex logic, you can swap in OpenAI's GPT-4o. The developers also call out Anthropic's Claude 3.5 Sonnet as being amazing for actual coding logic and refactoring. And this is the kicker. If you're in a high-security environment, you can even hook it up to local models through Llama for total privacy.
Okay, so you've plugged in your AI of choice. What can you actually do with it? Let's get into its auditing features, which are really all about checking the future health of your codebase. One of the big things it audits for is 12-factor app compliance. If you haven't heard of it, don't worry. Just think of it as a set of golden rules, a blueprint really, for building modern apps that are going to be robust and scalable when you deploy them to the cloud.
So what's it actually hunting for? It's looking for the stuff that becomes an absolute nightmare in a Kubernetes or serverless world. Things like, is your app truly stateless? Did you accidentally hardcode an API key somewhere? Are you using environment variables correctly? The little things that can bring an entire production system crashing down.
And this is where the whole thing gets really, really compelling. Because being cloud ready isn't just some technical checkbox. No, bad architecture costs real money, a lot of it.
Which brings us to the famous term, technical debt. We've all heard it, but it always feels kind of fuzzy, right? CodeMender tries to make it concrete. It's the cost of rework. It is the bill that eventually comes due for the shortcut you took today.
The tool basically quantifies this debt in two main buckets. First, you've got the algorithmic cost. That's just the raw inefficiency of your code. And then there's the cloud impact, which is how that inefficiency translates directly into a higher bill from AWS or Google Cloud.
So here's a perfect real-world example. The tool can spot something like a nasty nested loop, an O of n squared algorithm that runs just fine on your MacBook, but will absolutely melt a server under real traffic. But then it goes a step further and actually estimates what that bad code will do to the CPU and RAM usage of a serverless function. It connects the dots from bad code straight to your wallet. Okay, so it finds problems, it estimates their cost, but it doesn't just leave you hanging. This next bit is all about helping you plan for the future, moving beyond just fixing code to really visualizing your architecture.
Now this is really cool. It can generate a scalability heat map that visually shows you which parts of your code are like a big tangled monolith and which parts are nice and modular. And based on that, it can even suggest a migration path, basically a roadmap for how you could refactor a massive, complex function into its own scalable microservice.
It's not just flagging problems, it's proposing architectural solutions.
So if you're thinking, all right, I want to try this, the process looks pretty simple. You just pop into your VS Code settings, search for CodeMender, pick your AI provider from the dropdown, paste in your API key, and you're good to go. After that, just highlight some code, right-click, and hit Analyze Logic.
And that brings us right back to the beginning, to the most important question this tool makes you ask. Is your code just correct? Does it run without errors? Or is it truly architected for the future? Is it robust, cost-effective, and ready for whatever scale you throw at it tomorrow? That's the real challenge. Thanks for tuning into this explainer.